All right, we're gonna continue with the stream. We're doing Rustlings, and also using the Rust book. Yeah. So we are gonna look at structs. Yeah. Oh, I want to open this. Okay. The general syntax for struct key value pairs. Yeah. And we use dot notation to access the fields. Yeah, if the instance is mutable, then we can change it using the dot notation. There's also a field shorthand, which is like this. Okay. We can also create instances using the update syntax. How does that work? Basically, we want to create a struct, a new instance of a struct from a previous one, updating some fields. Okay, this is how you would normally do it, but yeah, you can use these two dots to say you want the remaining fields to come from user one. So the remaining fields that are not explicitly set should come from user one. And it has to come as the last. Must come last, specify the fields at the two dot notations, yeah. Or the update part must come last. Okay, Tuple Structs now. I think these ones are called what is that? This is like regular struct, I guess. What a typical struct. And Tuple Struct. So this is how we define a Tuple Struct. The struct keyword, of course, the name, and then the types. So we don't have to provide names for the fields. Okay, and then the unit struct. Yeah, it just doesn't have any parameters. Yeah. Useful when you want to implement a trait of some type, but you don't have any data. Yeah. Ownership of struct data. So structs can actually have references to data stored by something else. We are going to have to use lifetimes for that. Because we don't want, we want that the field remains in scope as long as the instance is in scope, right? So the field should not go out of scope before the instance. So we have to manage that with lifetimes. Yeah, lifetimes ensure that the data reference by the struct is valid for as long as the struct is. Like this is username is a reference to the string slice. Email as well. And this would not work to complain about needing lifetime specifiers. And then this is what it says. So you have to. Okay. So you need the display trait to do print line, of course. So it doesn't implement stdfmt display. So this is the derive trait or a debug trait that you're adding the attribute derive debug. Yeah. This allows the display trait. Yeah, I mean, it allows you to print the instance of the struct. Right. Okay. I think that's pretty it. Okay, this is about methods. Yeah, this is working with structs. And for you to have a method, you use the implementation keyword. Same name as a struct name, and then you specify your method. Yeah. Wait, yeah, it has to take a self or a reference to self, which is also a rectangle. Yeah. think that's what they were mentioning here. In the signature for area, we use the reference to self instead of rectangle. Yeah, you can do this, but then the self is actually short for this. Okay. So we are using the ampersand there in front of the self shorthand to indicate that this method borrows the self instance. Yeah, borrows it immutably. Yeah, we don't take ownership. We just want to read the data in the struct, not write to it. If we wanted to change the instance that we've called this method on as part of the method, we'd use mutable reference to self as the first parameter. Yep. What else? What else? What else is important here? Yeah, it's a method. You're just reading this. Okay. Wait, what does this mean? Where's this operator? If you're calling the method on the object directly and you use this, this is dereferencing. Rust doesn't have the equivalent operator. Instead, Rust has a feature called automatic referencing and dereferencing. Calling methods, some of the few places with this behavior. Right. So when you call a method with, let's say we do object or something, Rust automatically adds the reference in front of it, or mutable reference in front, or the dereference in front of it. So that object matches the signature of the method. In other words, the following are the same. P1 the distance, and then reference to P2. Or you do reference to P1 dot distance, reference to P2. Okay, the first one looks much cleaner. Okay. So basically it's automatic referencing and dereferencing. So why does it work? Because methods have a clear receiver, the type of self. Giving the receiver a name of a method, Rust can figure out definitively whether the method is reading reference to self, mutating it, or consuming self. Okay. And this is done because of ergonomics. So this is just for method receivers. Okay. Basically, the compiler can figure, Rust can figure that out. Methods with more parameters. So what? Yes, that's fine. Associated functions. So all functions with the implement a block are called associated functions because they're associated with the type named after the implementation. So yeah, that's what those all functions with within the implementation block. Okay. I mean, in like Java, for example, these are instance methods basically, but they're called here associated functions because they're associated with the rectangle. Yeah, we can also define associated functions. No. So these are actually associated functions. They are not methods. So they're only methods when they take self as in like reference self or mutable reference self. Yeah, these are just functions, or as it were, associated functions. Okay. Right. Yeah, you just call it the same way. Like you would call a regular method here or a function. You'd use the type, then you call it like that. Okay. And that's because there's no, it's not a method, so you don't need an instance to invoke it. So you use the type like this here. All right. So multiple implementation blocks. You can have multiple. There's no reason to separate these into multiple implementation blocks. Yeah, what is valid? Okay. All right. Yeah, I think we saw the syntax for tuple structs, right? Let me just look at that again. Where did we see tuple struct? Was it here? I think it was most likely here. Yep. Yeah, this is basically a tuple struct, and the unit struct is just like this. Okay, so I think that should be it with structs, apart from the lifetime thing that we will have to look at later when we get to lifetimes. Yep, that's it. So yeah, method syntax, is it not? Yeah, we already looked at that. Yeah, so we can try to do the rustlings here for structs. Right. So what do we have here? You might actually try to play this thing. No, it stopped. Okay. So we have color regular struct. We should add the fields at the test regular struct expect. So where's regular struct? Here. Regular struct. It expects but it's going to try to create an instance green. So it expects the fields red, green, blue. They're all integers. Okay. And it says what type should the fields have? What are the maximum and minimum values of the RGB colors? Yeah, 255. Yeah. So as red. That's I think the smallest, yeah, would work here. Syntax error. How does that? This is like so. We'll see. Red, green. Yep. Okay. Then what else is there? We have color tuple struct. So now we're doing tuple struct. We should add the fields that it says tuple struct expects. There's a tuple struct here, and it expects just green. Wait, hold on. No, green is the instance, and it expects 3 fields or properties, as you can call it here, but it is a tuple struct. So yeah, I think we don't need that, so we can do so we just need the types here because it's tuples, right? So we can do U8 and U8 as well, right? I think that's pretty much it. Then next this is a unit struct, yeah. It also has the attribute that allows for display. Then so now we can do how do we so green is going to be, what do we call that again? Color regular struct. I think, yep. Then we can say red. I think it was 0, right? Green, blue, or 0, 2, 5, 5, 2, 5. Yeah. What's this? Missing structure fields blue. Oh, I didn't make this blue. Yeah. And that is taken care of. The next test is okay. Yeah, and this is we're creating a tuple struct here, right? So I think it should be tuple or color tuple struct. Color tuple struct. Here we pass the values here, right? So what's that, 0? Yeah, 1 second. Right, so let's continue. And then last, instruct this should be start of word or yep. So instruct what was the name? It's called units. It's called instruct. Do we need this? I don't know. Yeah, we don't need that. Okay. Okay, so something fails here. Regular struct fails. No, it's here. Regular struct red, green, blue. 0, 255. 255. Oh, 0. Yeah, it passes. Next. Okay. All right. Okay, let's continue. So we have this struct order. It has these fields, and we have a create order template, which gives you an order, which is this is a it's just a function. It's not even an associated function, and what do we have? I have a test. We create a variable or declare a variable. Let order template be, and then we call create order template, which yields an order. Yeah. Now we should create our own order using the update syntax and the template above. So now our order will be oh no. Our order will be order. Yeah. No wait, not like yeah, order. I want to do the oh yeah, so we have to have a name which has to have particular things. The other one is Bob and the rest. So okay, wait. So yeah, so we have to only change name. Name is hacker in Rust, and then the rest, and then count also is something we also have to set. Is 1, and the rest things will come from order template. Oh, no. Mismatch types. Yeah, it's not a literal. Is it? Name is a string, so I have to say no. How do you change this? Oh wait. No. Anyway. Yeah. It compiles. So we'll do the next one. One second. Yeah. So let's do this one and then just take a break and come back after. Yeah, this will be that with structs, and then we can do the other ones. So structs contain data but also have logic. We have defined package struct. Yeah, this is a struct. I want to test some logic attached to it. So we have sender, recipient, weight in grams, and we have an implementation here, and we have a method which is new. This isn't how we should handle errors. Yeah, okay, that's fine. Yeah. So what we should do here is we should add the correct return type to the function signature. So if it's international, read the test and use the method to find out when a package is considered international. Excuse me. So where's the international one? Yeah, international package. The sender country is Spain. Recipient country is Russia. Package just is international. Okay. So this returns boolean bool. I want to use a match. Sender country. Spain. So the arms. Actually, no. When you want to match, it's not like so. It's not how you match. I think we can match on self, I think. And then or maybe even like this. And then for the arms, we can say this is I mean, this is better to just do an if. It's probably not the best case for it. think I don't need an if condition here. I just need to do this. Can compare. Okay. Wait, you can compare. Country is what? Is string, and you cannot compare with this. Why is that? Is it because it's a reference? Okay. Yeah, that's why. Okay. And it says it creates an own instance. This one creates an own instance for this. So it's comparing that creates an own instance just for comparison. So what other so compare owned. So it's trying to say we can use okay. Oh yeah, so because we're using the comparison operator here, then it knows to use compare owned. Nice. Okay. And next we need to do get fees. So we calculate the package's fees. We have cents in gram. Do we have any tests for fees? Yeah, transport fees. Sender country Spain. So the cents per gram is 4,500. Is it sorry, cents per gram is 1,500 based on this, right? So because this is 3 and then it's 4,500. So it's 1,500. Oh yeah, it's even here. Weight in grams, 1,500. And then the fees is get fees is the cents per gram. Cents per gram times weight in grams. Yeah, we need to return something. What is, yeah, it's AU32. Yeah. Yeah, it's done. All right, so I think we're done with. Next is enums, right? So I'm gonna take a break. We come back afterwards. Cheers.